Hey everybody, flipping with Bennett here. Welcome to integration on inverse trig functions. So we got a few examples we're going to do. We've got 4. We're probably going to break this up into a couple videos. So right off the bat, let's look at the 3 most common integrals that you're going to see on the AP exam, and that's the integral of 1 over the square root of a squared minus u squared, the integral of 1 over a squared plus u squared, and the integral of 1 over u times the square root of u squared minus a squared. And so take a second, copy these properties on. I'm primarily on the first 2 examples going to be knocking out these 2 because these are the 2 that you're probably going to see on the AP exam. Most likely they usually throw one of those in here. So it gets a little confusing, but we'll see if we can get you straightened out. So let's look at our first example. Okay, so we have the integral of x dx over 1 minus x to the 4th. So this is where it gets a little bit different with the u substitution because we've done something a little bit different before. So let's go ahead and rewrite this as 1 minus. We can do this now as x squared squared. Okay, so we're actually, in this case, going to let u equal x squared. Okay, so that means du equals 2x dx, and that means dx is equal to du over 2x. So there we go. Now it's a matter of substitution. So I found my u, so let's go back through. And I'm going to have x over the square root of 1 minus u squared, right? There it is, u squared, because u is x squared. And then we're going to multiply that by du over 2x. And so now some things simplify. We want the x's to be gone. They actually become 1. Let's swing that 1/2 out front, okay? So we have now 1/2 of the integral of du over the square root of 1 minus u squared. And if you look back at the definition here, if I sneak that back on here, there's our first definition, a squared, u squared under that radical. So this is just 1/2 inverse sine of your u value. Our u value in this case is x squared, plus c, and there is our original function. Okay, so that's our first example. Let's do one more in this video, and we'll break it up. We don't want to make a 10-minute video here. All right, this one needs a little more work. So we have the integral of dx over 9 plus x squared. So this doesn't have a radical. So this is actually, we're thinking about tangent here. This one is a little more algebra based, so let's go ahead and look at what we can do. We're going to say dx over, I'm actually going to factor the denominator. I'm going to pull out the 9, and I'm going to have 1 plus x over 9, and that whole thing, we're going to have that squared, okay? X squared over 9. So lost my train of thought there for a second. So now let's do a little bit more. Notice how 9 is a perfect square. So let's first we're going to bring this 9 out, 1/9. Then we're going to have dx over 1 plus x over 3 squared. So now I have my u value. I've done all this algebra, no u value yet. So u is going to be this value here, x over 3. Well, that means du is equal to 1/3 dx, and that means dx is equal to 3 du. So now here comes the substitution. So I substitute what I know back in, leave the 1/9. dx is 3 du, there's the numerator, over 1 plus u squared. The 3 becomes 1, this becomes 3. So technically we're left with 1/3 times the integral of du over 1 plus u squared, and there we go. There's our tangent we want. So this becomes 1/3 inverse tangent of our x value, our u value, which is x over 3, and that's just plus c. Okay, so there's our first 2 examples, about 4.5 minutes in. So we're going to do 2 more examples on a second video, but those are our first 2 examples of how to take inverse trig functions. If you have any questions or comments, you can type them below. We'll see you next time.